about Bohr's energy levels, and the energy level diagrams. We're going to look at something that's referred to as a Bohr diagram, a way that we can draw the elements, and then the simplified electron configurations. So helium, it's an atom whose atomic number is 2. Atomic number is the number of protons, so it has 2 protons. So if this is the nucleus, we would put in the 2 protons. And because it's an atom, that means that the number of electrons equals the number of protons, so it has 2 electrons. Now, the helium, its most common mass is 4, so that means that there are 2 protons and 2 neutrons in its nucleus. These dotted lines represent the energy levels. So the energy levels numbers, the energy level closest to the nucleus is energy level 1, energy level 2, energy level 3. Yes, it does have 7, but we just draw enough based on where the electrons are occupied. So electrons, when you're drawing the Bohr diagram, they want to be as close to the nucleus as possible. So when we're assigning electrons, we always start by assigning electrons in energy level number 1. And remember, we use that math, 2n squared, to figure out the max number of electrons. Energy level number 1 can hold a max of 2 electrons, so helium only has 2 electrons. So electron 1 and electron 2. Make sure you put the lowercase e with the minus sign for each electron. I'll come back to the configuration here in just a minute. So I'm going to move this up. And we're going to take a look at oxygen. So oxygen's atomic number is 8, therefore it has 8 protons. It is referred to as being an atom, so therefore it's neutral. So the number of electrons is equal to the protons, so we understand it has 8 electrons. Now if you draw out an atomic symbol for oxygen, its probably most common one, atomic symbol, will look like this. So it has 8 protons in its nucleus, the mass being 16. So we understand that there more than likely are going to be 8 neutrons. Now, the dotted lines, once again, represent the energy levels. So the energy levels are assigned from the nucleus and away as 1, 2, and 3, all the way out to 7. Once again, we'll just draw enough of them for where we will be putting electrons in. So we have 8 electrons. And remember, for assigning the number of electrons, it's 2n squared. So we have 8 electrons to place, but energy level number 1 holds a max of 2. So I placed 2 electrons there. So we have 8 electrons. I've placed 2, so now I have 6 more to place. Energy level 1 is full, so the next best choice is energy level 2. 2n squared, second energy level, can hold a total of 8, but I only have 6 to place, so all 6 remaining electrons can be placed here on energy level number 2. Now, the electron configuration. All it shows are the electrons moving from energy level 1 towards 7. So energy level number 1 has 2 electrons. So I'm going to put 2. I'm going to put a dash line because that'll separate the information from energy level 1 and energy level 2. And then I place 6 electrons in energy level number 2. So the first number, always to the left, is always the number of electrons in energy level 1. The dash line, it separates the energy level information. So we know when we see the dash line, we're on to a different energy level. And then since 6 is the next number in the configurations, that would be the number of electrons in energy level 2. Let's take a look at one more example. See if I can move up just a little bit. Okay, so our next example is phosphorus. Phosphorus's atomic number is 15, therefore it has 15 protons, and because it is designated as being an atom, it is neutral, so it also has 15 electrons. Now, phosphorus, its most common atomic symbol will look like this. So we know that it has 15 protons in its nucleus. 31 minus 15, that will give us our number of neutrons. So we know that there are 16 neutrons. And then we have our electrons to place. So the energy levels, we always start at number 1 and work our way away from the nucleus towards energy level number 7. So we have 15 electrons to place, and we're going to start at energy level 1. And remember, it's 2n squared. So the max number of electrons we can place in energy level number 1 is 2 electrons. So out of the 15, I've placed 2. So that means I have 13 more electrons to go. Then I move on to energy level 2. 2n squared tells me I can place a max of 8 electrons in energy level 2. So I have 13 to place, but I can only put 8 of them in energy level 2. 1, 2, 3, 4, 5, 6, 7, so I gotta put 1 more. So now I've placed 8 and I have 5 more to go. So energy level 3 is open, 2n squared. I can place up to 18 electrons in energy level 3. I have 5 to place, so my remaining 5 can go in energy level 3. So remember, the Bohr configuration, it's the number of electrons I placed in energy level 1, which is 2, a hyphen to separate energy level 1 from energy level 2's information. I placed 8 electrons in energy level 2. And now I'm going to put another hyphen because I actually put electrons in energy level 3, and I placed 5 electrons in energy level 3. So I know that I didn't do the electron configuration for helium, so I'm going to go back up to the top here. And so helium's electron configuration is very, very short because we only put electrons in the first energy level. So it's just a 2. All of the other energy levels are empty. So, it would be awful to write 2-0-0-0. So we only have electrons in energy level 1. All of the other energy levels 2 through 7 are empty. So instead of writing all of that out, we just only include the energy levels that are occupied. So helium's electron configuration would simply be a 2.